The preservation of the highest sensitivity to the detection of ventricular arrhythmias is an absolute requirement of all algorithms that may inhibit the therapies. The SecureSense algorithm includes a protection against undersensing on the discrimination channel. The algorithm is withheld if at least one event among the following three is observed during an episode of arrhythmia. 1. At least 2 VS2 cycles with an amplitude of less than 0.6 millivolts, or 2. A pause between 2 VS2 cycles of at least 2200 milliseconds, or 3. The detection of only a single cycle on the discrimination channel during the episode. The SecureSense algorithm is then automatically reprogrammed to passive during an episode, and an undersensing alert appears on the programmer. This is here an episode of non-sustained ventricular tachycardia, wrongly diagnosed by the device, non-sustained RV oversensing. You can see on the EGM that initially the patient is biventricularly paced, and then the onset of a real ventricular arrhythmia after 2 short cycles and a warm-up of 350 milliseconds. There is initiation of the noise counter, but you can see that clearly there is undersensing, since there's no markers VS2 on these 2 cycles. Then you will see that there is intermittent correct sensing at the level of the discrimination channel, since 1 signal out of 2 is sensed. The noise counter is incremented by 1 after each short cycle detected in a bipolar channel, and it is not reset to 0 since there is no short cycle on the discrimination channel. This leads to the false diagnosis of non-sustained ventricular oversensing. There is then a spontaneous reduction of the arrhythmia. Now, this is another patient with 1 episode recorded as a VT, and then you can see what happens when there is undersensing on the SecureSense channel. Undersensing was detected on the SecureSense channel, and SecureSense was changed to passive automatically by the device, which means that now the SecureSense algorithm cannot interfere with the decision to treat or not to treat the arrhythmia. So to summarize, during a sustained ventricular tachyarrhythmia, 3 situations are therefore possible, depending on the quality of sensing on the discrimination channel. If sensing is of good quality, the occurrence of short cycles on the discrimination channel regularly reset the noise counter to 0, and the therapies are not inhibited by the algorithm. If the quality of sensing is poor, like in this tracing, at least 1 of the 3 criteria is filled, and then the SecureSense algorithm is interrupted and reprogrammed automatically to passive. An alert appears on the programmers, and the therapies are not inhibited by the algorithm. In very, very rare cases, undersensing is intermittent, like in the first tracing, with a risk of inappropriate inhibition of the therapies. However, the risk is very low, and in a large study carried out in our medical center, we observed no prolonged inhibitions of the therapies that might have threatened the patient's well-being. The risk of undersensing an episode for a long duration while not fulfilling at least 1 of the 3 previously described criteria is very low. When the sensing quality on the discrimination channel is not perfect, the sensing settings on this discrimination channel cannot be changed. The blanking, threshold start, decay delay, and ventricular sensitivity are not programmable on this channel. The only parameter you can change is to reprogram the discrimination channel from coil to CAN or tip to CAN.